For question 1 of exercise 9a, they're asking you to show the first principles differentiation of cos x. And so the way we do this is we think of a point here that is x and cos x. And we have another point here that's ridiculously close to it. That's x plus h and the cos of x plus h. And the idea is we're trying to find out its gradient. So we're trying to see how far up divided by how far along as this point gets closer and closer and closer there. And so the differential is the limit as this h gets closer and closer to 0. So the limit as h tends to 0 of this one here, the cos of x plus h minus the cos of x, so the difference in y's, all over the difference in x's, which of course is that one, take away that one, which is just h. So now we've got to do some maths with this bit here. And the first thing we're going to do comes back from a chapter a little while ago, the cos of x plus h. Let's expand that. Expanding that, the cos one was cos minus sin. And then this is all still here as before. So, looking at this then, we're going to split it into two parts. The first part, I'm going to look at all the things with a cos in. So this gives me the cos of x times by cos h take away 1 over h. And the other bit is just this bit here. So I've got sine of x times by sine h over h. And we need to do the limit of all of that. And then that is what they were asking us to show in the first part. It does say keep going. So if we keep going with this, just looking at this bit here, and you know that the sine of h over h, for very small values, the sine of h is roughly h. And so this gets closer and closer to 1. Whereas this one here, this part here, gets the limit of that one gets closer and closer to 0. So you're left with, I'm struggling how to write with this now. I think we've done our limits. So I think what we normally write here is we normally write that the limit as h tends to 0 of cos x minus 1 over h equals 0. That bit's 0. And the limit of sine h over h equals 1. That bit's 1. And so therefore f dashed of x is equal to nothing times that and 1 times that, which is minus the sine of x.